All right, so 3, 7, 19. Okay, so here's our objective. Today what we want to do is we need to graph parabolas in vertex form, okay? So vertex form is the form we like, but it doesn't give us everything, okay? Standard form has an advantage on one thing, vertex form has an advantage on the other. So let's take a look at both. So vertex form, y equals sum a times x minus h squared plus k. Now that's a standard formula. That's why we use h and k. It's a standard formula because h and k represent numbers, just any numbers. That makes sense. It could be a 3, a 2, it could be whatever. But h and k, and the number a is either the stretch or the shrink, okay? But we use variables to represent any parabola, okay? So we know that the vertex from this is at hk. And again, we always take the opposite of this, and that's why that says negative. Because in math, a negative or subtract really does mean opposite. And that's why you get the negative here in the formula, okay? We also know that a is either a stretch or a shrink, right? The value of a is either a stretch or a shrink. It's a vertical stretch. Vertical, sorry it's so sloppy. Sorry it's so sloppy. So the value of a is either a vertical stretch or a vertical shrink, right? So this is a general formula, okay? Now, one of the things that we don't get from the vertex form is we don't get the y-intercept. This number is not the y-intercept, okay? So check this out. This 5, it's not the y-intercept at all. Does not even go through 0, 5, okay? So you got to be careful. This is not the y-intercept. How do you find the y-intercept? Well, let's look at a picture. So if I draw a picture of any parabola, okay, I know that my y-intercept is on the y-axis, and that's when x is 0. So how do you find the y-intercept? Always, yeah, we let x equals 0. Or what Olivia says, just plug in 0. Does that make sense? If you plug in 0, so in this case, if I plug in 0 and solve it, I'll get my y-intercept. Does that make sense? If I need the y-intercept, I'll let x equals 0, and I solve it. And we will do this, okay? Okay, now the x-intercepts, if I take a look at these two values, those are my x-intercepts, and that's when the y is equal to 0, right? So it's a height of 0. Sometimes we find that by factoring, which we've done before. Like in our warm-up, if you take a look at our warm-up, we actually found the zeros, right? Because we set it equals 0, we factored. And then sure enough, when Austin graphed it, those were our x-intercepts, right? See how it works? When we set it equal, find the zeros by factoring, we get the x-intercepts, okay? So let y equals 0 and solve. Now, in the case of the x-intercepts, 2 answers. Do you agree with that? 2 answers? You guys see the 2 answers? So a lot of times, not always, a lot of times there are 2 answers. But not always. Not always. In fact, let me go to the whiteboard and I'll show you, okay? In this example, yeah, 2 answers. Answer here and answer, okay? But it's possible to graph my parabola like this. You guys watching? That's one answer, right? And that's where it happens twice. Remember how we solve these? Sometimes you get the same answer twice, okay? And, hold on Chase, I'll answer your question in a second. And it's even possible to have something like this, which would have no x-intercepts, right? Chase, question.
What would happen if you plugged in 0 for one of those equations?
One of these equations?
As y?
We're going to do that.
Just like...
Yep, we're going to do it. In fact, hold on to that thought and we're going to do it, okay? Really good question, okay? It's part of my lesson. Thank you. You're ahead of me. I like that. So now let's take a look at example number 1. Find the line of symmetry and the vertex, okay? So if I want to go ahead and find the line of symmetry, that's easy. It's in vertex form, right? It's simply going to be that number there. But the opposite, right? So in this case, my line of symmetry is simply x equals negative 4. So if I have my graph, and I'm just going to do a really rough sketch of my graph, okay?
Draw this graph.
You don't need to. You can just watch. I know that at 1, 2, 3, 4, I'm going to have a line of symmetry, which is my reflection line, right? That's my reflection line? Yeah. Now, on that line of symmetry has to be the vertex. It's got to be, right? I mean, if it's the folding line, then the vertex is on it. So how do we get the vertex? Well, the vertex is simply going to be at negative 4, 5, okay? So negative 4, 5 is, let's see, 1, 2, 3, 4, 5. It's right there, okay? All right, now if I look at this, now if I think about what's going on, yeah, Abby?
Why is it negative 4 and it's positive 4?
Always the opposite side, and let me explain why it's the opposite. So if this is my lowest value, right? You with me? What number here would make this whole thing 0? It's got to be negative 4, right? So when you use the opposite, it zeroes it out, brings it to its very bottom spot. That's why it's always the negative. Good question. Now, if I wanted to really graph this parabola, it doesn't say it, but if I want to graph this parabola, I need 3 points. I got to have 3 points. I only have 1. So let's find the y-intercept. It is not 5. So how do I get the y-intercept?
You solve when 0 is x.
There you go. So let's go y equals 2, 0 plus 4 squared plus 5.
Wait, can you scoot it over a little?
Yeah.
Thank you.
Okay. And I'm going to do it 2 ways. I'm going to do the math in my head because I can. And if you can't, I'm going to show you how the calculator can do it for you, okay? So being a math guy, I'm going to go 16. 4 squared is 16 times 2 is 32. 32 plus 5 is 37. So the y-intercept is y equals 37, or it's a 0.037, okay? Right? Now, so you can't do it in your head? It's all right. Maybe your gift is in English, not math. Use the calculator, right? So I'm just going to go 2, watch this, parentheses 0, plus 4, parentheses squared, plus 5. Okay, there it is, right? Let the calculator do the work. You guys see that? Enter. 37. So again, I don't mind if you use a calculator. If you need to, that's fine. So if I go back to my graph, I'd have to go way up to 37. So let's just imagine way up here, because I'm going to be off the page. That is at 37. You okay with that? So is there a third point? Sure. Third point's got to be over here, right? So if I fold it over, all right, so the graph looks kind of like that. We don't have to have a perfect graph, but it looks something like this, okay? Now, let me ask you an easy question. Easy question. What about the X-intercepts?
The 0 from Y.
You could, yes.
Or just use the graph.
Yes, so let me ask again. What do we know about the X-intercepts?
They're on
There's none. There's none. Does it ever cross this line? Will it ever cross this line? No. So X-intercepts, X-intercepts, none. Okay? You're right, though. We're going to do that later, okay? All right. Example 2. So let's compare these two. So in words, what's happening from here to here? If I have a regular x squared and the regular x squared, you don't have to graph this, but I'm going to sketch a graph anyway, okay? Here's my regular x squared graph, my parabola, okay? There it is. In words, how do I go from x squared to a 1/2 x minus 3 squared plus 1?
Well, it gets flipped upside down and moved up 3.
Okay, let's rephrase that a little bit. Let's move it to the right 3, you with me? And up 1. You guys okay? So we're going to
Wait, why did you move it?
opposite, right?
Okay, yeah.
Opposite. So we're going to translate it 3 units right. And the reason I'm going to the right is because, remember, it's the opposite. So instead of -3, we go, remember the dance, remember the silly little dance we do? a dumb dance to do, right? It's on the inside. It's the opposite horizontal. It's a stupid dance, isn't it? But you won't forget, hopefully, right? Right, it works, right? And then what else we know? We know we're also going to go up 1 unit. Okay? Everybody good on that?
Why did you go up one, only one?
Positive one right here.
Oh, okay.
Good. Now, what about the 1/2?
That's a shrink.
It's a shrink. So we also know it's a vertical shrink. So it's a vertical shrink of 1/2. So my translated graph is going to be about here, but half as wide. Can you see it? Now that's just a rough sketch of it, but I've moved it to the right 3, up 1, and it's half as wide, or half as tall. Can you see how those two compare? Original parabola. This one's been moved 3, 1, and it's half as tall. Okay, thumbs up. Does that make some sense what I did? Okay. Okay, you ready to turn the page? Okay, now, on example 3, we're going to actually have to graph, and we're going to have to get the X-intercepts. Okay, now this is the one I want to show you. Here comes the tricky part. So let's get the easy stuff. If I look at this, tell me first of all, what's the easiest thing to find out in example 3? The vertex. Who said that? Thank you, Owen. The vertex. You guys agree? So if I have to find the vertex, what is the vertex? -1, -4. Everybody agree with that? So we got something, and I'm going to graph in the end. I'm going to get all the information, then I'm going to graph. Okay, does that make sense? Okay. Now I also know a line of symmetry, don't I? What's my line of symmetry? X equals -1 because it has to go through the vertex, right? Line of symmetry goes right through the middle of the graph, so it's got to go right through there. Okay. Now, X-intercepts. Let's do that. Okay, X-intercepts. Let's do that. So, let y equal 0. So 0 equals x plus 1 squared minus 4. Okay? X-intercepts. How many answers? It's got to be 2. So somehow I've got to get up with 2 answers, okay? 2 answers, okay? So before I do this, I'm going to ask you a really easy question, okay? You ready? Easy question. 2 times 2. -2 times -2.
4.
So that means there's 2 answers to make 4. I could go 2 times 2 or -2 times -2. You guys agree with that?
Yeah.
So let's see how that's going to help me, okay? So let's solve. What am I going to do? Plus 4, right? Plus 4, plus 4. So I'm going to get a 4 equals x plus 1 squared. How am I doing? And when I solve, I always do the opposite, right? So to do it in a square, I'm going to do a square root to undo it. Okay, square root to undo it. So I'm going to take and square root both sides because my square root cancels the square root. Does that make sense?
Yeah.
And I squared here. But what's the square root of 4?
2.
And -2. It's both. It is, so we're going to get a plus or minus 2, okay? Now here's where it gets tricky, all right? And I know you're smart enough to handle this. Square root of 4 is 2, right? But you have to have 2 answers. You have to have 2 answers. So I know that 2 times 2 is 4, and I also know -2 times -2 is also 4. So I get 2 answers. Now, what I need is mini equations, okay? I need a mini equation. I need 2 mini equations because I need 2 answers. Well, one mini equation is this. 2 equals x plus 1 and -2 equals x plus 1. Now, that's kind of weird, isn't it? But it's going to work, okay? I mean, same kind of thing. I've got many equations, but instead of zeros, I've got a 2 and a -2, okay? How am I doing, okay? I'll back you up. Took the square root of 4, I got 2, but I got 2 and -2, okay? Back you up. I took the square root of 4, I got 2 and -2, right? So I set 2 equaled x plus 1, and I set -2. Okay, let's solve this. It's easy to solve now. -1, -1, I get x equals 1. So that is an x-intercept at 1, 0. Circle that. That's my x-intercept. -1, -1. I get a negative 3 equals x, or I get an x-intercept at negative 3, 0. I'm going to circle that, okay? Okay, I've got just about everything I want to graph this. Just about. Okay, one last thing I want to do real quick is find the y-intercept, okay? So now, over here, I'm going to find my y-intercept.
Why are we gonna find the y-intercept if we already have the x one?
Because I want you to. Right, let's get everything, right? So it's just one more point to make it more accurate, I guess, Liam. How's that for a better answer, huh? That's a better answer than just because I want you to, huh? So, to find that y-intercept, let x equal 0. Okay, so let's do it. So I'm going to go, all right, y is equal to a 0 plus 1 squared minus 4, which is negative 3. And again, if you can't see the negative 3, just use the calculator. There's nothing wrong with using a calculator, but it is negative 3. So if you go parentheses 0 plus 1 squared, subtract 4, you get a negative 3, okay? You really do. So, because you get 1 squared minus 4, so we've got a point at 0, negative 3. Now, if I want to graph this, I've got everything I need, right? Everything's there. Let's put it all together. So, xy axis, right? Okay, xy axis. And let's see what I have. Let's put down what I know. All right, what do I know? All right, well, I know a lot. I know I've got a vertex at negative 1, negative 4, right? There's my vertex, right? I've got a line of symmetry, which has to go right through that, right? Okay. How am I doing, okay? I have x-intercepts at 1, 0, and negative 3, 0. Okay? And I've got a y-intercept at 0, negative 3. Now, really have another point. I got 4 points. I really have a fifth point. Where's my fifth point? Perfect. Awesome. Totally right. You guys agree right there? There's my fifth point. So, yeah, I got lots of points, right, Liam? Which makes it super accurate. Because you asked a pretty good question, Liam. It's like, why should I do all this? Because I could probably graph it from the other. You're right. But now it's super nice and accurate. How's that? Thumbs up? It's a lot of work, but it's not hard, right? Okay, last but not least. Last problem. Okay. Now, okay, I got to graph this parabola. It wants me to put it in standard form. Okay, standard form is like ax squared plus bx plus c. But before I do anything, is there something I could take? What can I grab from this form? Before I mess it up and wreck it, what can I get from this form?
Line of symmetry and the root.
Yes, you guys agree with that? So before I multiply it all out and mess it all up, let's take what I know. So I totally agree. Let's take and put our line of symmetry. We know is our line of symmetry is at our x equals negative 1. That's my line of symmetry. And we know our vertex is at negative 1, negative 5. Okay? You guys agree with that? Okay, I'm going to go along with what Owen said because now it's going to get easier. Okay, let me put this in black. It might be easier for you guys to see. Okay, now standard form. I'll go through it slowly. Y equals 2. I'm going to go x plus 1, x plus 1 minus 5. To be in standard form, I'm going to have to multiply it all out. Okay, it's kind of a pain. But once we get it, we'll get the y-intercept pretty easily, okay? So I wrote it twice because of the square. Okay, you guys see that? Quantity squared. So I wrote it twice, and now I'm going to multiply. I'm going to FOIL. All right? I'm going to go x times x. X times 1. 1x. 1 times x, 1x. 1 times 1 is a 1. Times my 2. Okay? Okay, good. I just went x times 1, 1 times x, and 1 times 1, okay?
So that's
X squared plus 2x plus 1, right?
yeah.
Because I added those. That times that, that times that, that times that. Or how about a 2x squared plus a 4x plus a 2 minus 5, right? And I'm going to be done in a second. 2x squared plus 4x minus 3. These two are the exact same equation. They really are. These two are the exact same equation. This one is in vertex form, which makes it really nice to get my vertex. This one's in standard form. What can I get from this that's so easy?
The X-intercept.
You meant to say, yeah, I knew you meant that. So yeah, the Y-intercept is really easy from this one, right? It's at 0, -3. And now, Leon, let's go with what you said, because we probably have enough. We're going to have 3 points. Do you agree with that? So now if we have to graph it, let's see what we have. Okay, so if we take a look and put down my XY axis, right? All right, let's graph this. And let's see what I have. I have -1, 1, 2, 3, 4, 5. I have a line of symmetry, right? Okay. I have a Y-intercept at 0, -3. I need a third point. Where's my third point?
Reflection.
Yep, right there. We agree. Third point right there. And we got enough, right? We got enough. If we wanted to get the other points, we could do it, but we're not going to do it, okay? How's that? That's my graph. Okay, that's all I have for you, okay?